Here's something worth thinking about as you settle in tonight. You can measure any civilization, from the Stone Age to a galactic empire, with just one number: how much energy it uses. Everything you did today required some form of energy. The kettle this morning, the bus, the phone, the light you switched off. And in 1964, a Soviet astronomer named Nikolai Kardashev turned that number into a ladder with 3 rungs. A civilization that commands the energy of its whole planet, of its whole star, of its whole galaxy. We call it the Kardashev scale, and it's how scientists talk about how far a civilization has come and how far one could possibly go. So after 300,000 years of campfires and cities and rockets, where are we? 0.73. We haven't even reached the first rung. So tonight we're going to climb the whole ladder, rung by rung, from your kitchen to the entire galaxy, and see what would have to happen for us to reach each rung and what the world would actually look like once we're standing on it. Along the way, you'll find out why the energy the sun gives off in a single second could run humanity for 600,000 years. Why a single bottle of seawater could one day power your home for a whole year. And why astronomers have already checked 100,000 galaxies for anyone who's finished this climb. And what they found is the strangest part of tonight. Nobody knows whether the ladder can be climbed, but nothing in physics says it can't. And somebody, somewhere, gets to be first. If you enjoy journeys that completely reshape how you see the universe, do me a small favor and hit that subscribe button. It genuinely helps this channel grow and lets me keep making these deep dives for you. Also, tell me in the comments where in the world you're falling asleep tonight. For now, dim the lights and settle in. I'll keep watch. Now, somewhere past your window, 400 billion stars are hanging in the dark, unclaimed. Let's begin. Start with the kettle, because everything tonight is in the kettle. Sometime today, you or someone near you filled one, clicked it on, and waited. Think about what actually happened in that minute. Water sat in a metal jug, and energy poured into it, and the water changed. That's it. That's the whole trick. And it's also, honestly, the whole of civilization. Warming things, moving things, lighting things, cooling things. Every city ever built is the kettle trick, repeated at larger and larger sizes. So when scientists wanted one honest way to compare civilizations across any planet, any biology, any history, they landed on the only thing every possible civilization has to share. Not language, not money, not wheels or writing, energy. Or, put the way this night will keep putting it, one question that works on every world that will ever exist. How big a kettle can you boil? Yours, tonight, held about 1 liter. Hold that number loosely. By the end of tonight, the kettle will be the size of a galaxy, and the strangest part is that no step in between will feel like a leap. And here's why energy is such a good ruler. It's music, it's politics, it's table manners, whether it drinks anything like tea, all of that could be anything at all. But energy is physics, and physics is the same everywhere. A civilization on the far side of the galaxy might share nothing with us, not one idea, not one shape. It would still need energy to do anything whatsoever, because doing things is what energy means. So you can rank every civilization that could ever exist on one simple line without knowing a single other fact about them. It's the kind of idea that sounds obvious once somebody says it. Somebody had to say it. The somebody was a radio astronomer in Moscow, and the year was 1964. Nikolai Kardashev was 32 years old, and he wasn't actually trying to rank civilizations at all. He was trying to answer a much more practical question. He was part of the very first generation of scientists pointing radio dishes at the sky and listening for someone else, the same young field we visited on another of our nights together, and a listener has a problem. How loud could a broadcast from another world possibly be? That depends on how much energy the broadcaster commands. So Kardashev, needing an honest way to think about it, wrote a short paper and sketched 3 sizes of civilization. Type 1 commands the energy of its planet. Type 2 commands the energy of its star. Type 3 commands the energy of its galaxy. 3 rungs, 1 ladder. He meant it as a working tool, a way to size up a signal. What he'd actually built was one of the great thought experiments of the century, and it escaped the paper almost immediately. It's worth knowing a little about the man, because the ladder makes more sense once you can see the person on the bottom rung, looking up. Kardashev spent his whole life listening. He'd grown up in Moscow, in hard decades, lost his father young, was raised partly by an aunt while his mother was taken away for years, and he found his way to the one thing that never stopped feeling large enough, which was the sky. By his early 30s, he was working with some of the biggest radio dishes in the Soviet Union, in an era when radio astronomy was brand new and every strange whistle from the dark might be anything at all. That's the thing to understand about 1964. Nobody knew what was out there making noise. The universe had just started talking to our instruments, and the people listening had to invent from nothing the categories for what they might be hearing. And within a year of drawing his ladder, Kardashev lived through the perfect story about how hungry those categories were. There was a radio source in the sky called CTA 102, a fierce little point of energy that nobody could explain. Kardashev suggested, carefully, in print, that a source like that was worth checking against his new ladder. A colleague of his watched it, found its brightness seemed to pulse, and in the spring of 1965 there was a press conference in Moscow, and for a day or so, headlines around the world carried the news that Soviet astronomers might have found a civilization far up the ladder. Even a rock band wrote a song about it. The truth arrived quickly, and it was stranger than the headline in its own way. CTA 102 turned out to be a quasar, one of the most violent natural objects in the universe, a giant black hole feeding in the heart of a distant galaxy. Not a civilization. Just the cosmos, being louder than anyone had imagined it could be. And that's been the pattern of this whole field ever since. And it's worth pocketing for later tonight. Every time we've caught something that looked like the ladder's upper rungs, it has turned out so far to be nature. So far, the ladder did something else in those years. Something quietly remarkable that had nothing to do with aliens. It gave the 2 halves of a divided world a reason to sit at one table. In 1971, at a mountaintop observatory in Armenia, Soviet and American scientists held the first great joint conference on the search for other civilizations in the middle of the Cold War, with their 2 countries' missiles aimed politely at each other the whole time. Sagan was there. Kardashev was there. So were Nobel laureates, biologists, anthropologists, a whole improbable guest list, gathered under one roof to argue about how often life arises and how long civilizations last, while being, themselves, the evidence under discussion. People who attended described something faintly comic and deeply moving about it. The species that couldn't agree on borders, agreeing enthusiastically about galactic engineering. It's a small preview of a theme that runs all the way up tonight's ladder. Thinking about the largest scales has a strange gravity to it. It pulls people, sometimes even governments, a little closer together. Because from the second rung up, none of our lines on maps are visible at all. Now, here's the part of the ladder that most people miss, and it changes how the whole night feels, how far apart are the rungs, because they are not evenly spaced. Each one stands about 10 billion times higher than the one below it. 10 billion times. Not double, not 10. A civilization stepping from rung 1 to rung 2 multiplies its entire world by a number with 10 zeros. Which means this ladder is nothing like a staircase. It's more like a path up a mountain range, where the first summit turns out to be a foothill of the second, and the second is a foothill of the third, and each climb is invisible from the one below. Hold that shape in your mind tonight. It's why this story has room in it for 100,000 centuries. And it's why the view from each rung is beyond anything the climbers below can picture. So, where are we? There's a lovely, slightly embarrassing answer. Kardashev's original ladder had no rungs between the rungs. You were type 1 or you weren't, the way you've either boiled the kettle or you haven't. It was the astronomer Carl Sagan, another name we've met on our other nights, who noticed in the 1970s that this left our own species standing nowhere at all, and worked out a gentler arithmetic, a way to give a civilization a decimal grade for how far up the gap it has climbed. You take how much energy the civilization actually uses, compare it against the rungs, and the formula hands you a number with a point in it, a grade for a species. Run today's numbers through Sagan's arithmetic and humanity scores about 0.73. Not 1, but 0.73. All of it, every power station and solar farm and engine on Earth, everything humming right now while you lie still, adds up to a civilization roughly 3/4 of the way to the bottom rung of the ladder. And be careful with that decimal, because it's wearing a disguise. Sagan's scale runs on multiplication, not addition, so every 1/10 of a point is a 10-fold leap. A 0.8 civilization isn't a bit ahead of us, it commands 10 times our energy. 0.9, 100 times. The little decimal walks like a percentage and climbs like a mountain, which is a very Kardashev sort of joke. The pyramids were rung 0. The printing presses, rung 0. The moon landings, the vaccines, the internet, the whole of what any schoolbook calls civilization, rung 0, still climbing. And notice the strange comfort hiding in the grading. A scale that files our entire history under approach walk isn't calling the history small. It's telling you how much room the story has left. Nobody writes a 3-rung ladder for a species they expect to stay in the yard. And there's something oddly comforting in that, before we've even started. Every marvel you have ever heard of happened below the first step. The whole story so far is the approach walk. The mountain hasn't even properly begun, and before the number moves on, make it personal, because the ladder isn't only for civilizations. You're on it too, your body, just lying there, runs on about 100 watts, the power of one bright, old-fashioned light bulb. That's you, a warm, thinking 100-watt device, currently in power, saving mode under a blanket. But your share of civilization's whole harvest, everything burned and captured on your behalf, the factories and farms and flights and server halls quietly working your slice of the world, comes to a few thousand watts, day and night, for life. In other words, you already live like a small aristocrat of the ladder, attended around the clock by the energy of a couple of dozen invisible servants, tireless, unpaid, made of sunlight and fuel. Your great-grandparents had a fraction of that staff. On rung 1, your descendants' staff is 1,000 strong, then 1,000,000 on the rungs above, and none of them ever tires. And that, at bottom, is what climbing feels like from inside a single life. Not power. Attention. The universe increasingly showing up to help. But here's the thing about that number. It's not an insult. It's a measurement, and measurements tell you where the road goes. To reach rung 1, humanity doesn't need to improve a little. We need roughly 10,000 times more energy than everything we currently use, all together. All at once. 10,000 times more. That's not a bigger power station. That's a different kind of civilization. And yet, and this is where tonight starts to lean forward, nobody serious thinks it's impossible. The energy is already here. It falls on us every single day for free, and we let almost all of it bounce away into space. The first rung of the ladder isn't hiding somewhere among the stars. It's hitting your roof tomorrow morning. Because look at where the energy of rung 1 actually is. Add up everything our civilization uses. Every car and furnace and factory and phone, and the sun delivers that much energy to Earth's daylight side in less time than it took your kettle to boil this morning. About an hour of sunlight falling on one small planet equals a year of everything humanity does. The gap between us and rung one isn't a shortage. It's a harvest we haven't learned to bring in. The whole first act of the climb, the act our great-great-grandchildren may live inside, is just this. Learn to catch what's already falling. But before we climb forward, it's worth climbing backward for a few minutes, because 0.73 didn't come from nowhere. It's the running total of the longest story our species has, and the story explains why anyone believes the ladder can be climbed at all. So, run it back. 1,000,000 years ago, give or take an argument, somebody's ancestor did the most consequential thing any creature has ever done, kept a fire instead of fleeing it. Every rung of tonight's ladder is downstream of that one wet, frightened, brilliant decision. Fire was the first energy our species commanded beyond its own muscles, and look what it brought. Cooked food, which meant more energy from every meal, which meant, over ages, the expensive brain you're listening with. Warmth, which meant the cold parts of the planet opened up. Light, which meant the day no longer ended when the sun went down. And stories at night, and protection, and metal eventually, and glass, and everything made of them. One campfire, and the whole address book of civilization starts filling in. What else in all of history ever paid back like that? And then, for hundreds of thousands of years, that was more or less the toolkit. Muscle, fire, and patience. Every pyramid, every harvest, every wall of every ancient city was built by bodies, fed by fields, warmed by wood. The first editions were quiet ones. Somebody noticed a river could turn a wheel, and suddenly grain ground itself while the miller slept, which must have felt like employing a ghost. Somebody hung cloth on a mast, and the wind, which had only ever been weather, became an engine that could move a family across an ocean. These sound small. They weren't. They were the first times our species used energy that wasn't food. Energy that didn't tire, didn't eat, and didn't die. The river doesn't rest, and the wind doesn't ask for wages. A civilization that harnesses them has quietly hired the planet. The next chapter is the strange one, and we're still living in its afterglow. A few centuries ago, in damp mines in England, engineers trying to pump out floodwater-built machines that drank a black rock and breathed fire. And what was that black rock, really? Something astonishing, buried sunshine. Coal is the compressed remains of forests that soaked up sunlight 300 million years ago, ages before the dinosaurs, and every lump of it releases afternoons that fell on ferns older than flowers. Oil and gas, the same older ocean's worth of tiny lives, pressed into liquid light. When our species learned to spend that inheritance, everything detonated at once, and you can put a date and an address on the moment the modern world switched on. On a September afternoon in 1882, in a converted warehouse on Pearl Street in Lower Manhattan, workers fired up steam engines connected to dynamos and a few streets worth of offices. Some 59 customers with a few hundred lamps between them became the first neighborhood on Earth lit by a central power station. One building, humming, and a handful of glowing rooms. Nobody watching that first evening could have guessed they were seeing the seed of a planetary organism. The thing that would grow into the grid, now humming behind your wall, the bloodstream every kettle on Earth drinks from. But that's the whole shape of tonight in one anecdote. Every planetary system begins as one warm room. Cities lit, distances collapsed, populations soared. In about 2 centuries, a blink, we went from candlelit kingdoms to a wired, flying, humming, planetary civilization. That's the surge that carried us from roughly 0.5 to 0.73. It came with a bill, as inheritances spent quickly tend to. And the bill is the century we're living in, learning the hard way that you can't burn 100 million years of sunlight in one long weekend without the house noticing. And one more chapter is already open. Within living memory, we found the trick underneath all the other tricks. Every fuel that ever was, wood, coal, oil, muscle, is just a way of releasing sunlight that plants once caught. But in the 1930s and 40s, physicists learned to open the atom itself and found energy that owes nothing to the sun at all. Energy left over from exploded stars, older than the solar system, sleeping in metal in the ground. A single pellet of nuclear fuel the size of your fingertip holds as much energy as a ton of coal. That's the trend line of the whole story. And it's worth saying plainly, because it's the reason tonight isn't a fantasy. Each chapter of the human energy story has found a source thousands of times denser than the last, on a schedule that keeps shortening. Muscle to fire took forever, fire to rivers took millennia, rivers to coal took centuries, and coal to the atom took decades. We are not a species standing at the bottom of the ladder wondering how ladders work. We're a species that has been climbing the approach slope, hand over hand, faster every century, for 1,000,000 years, and has never once stopped. And before we start the climb proper, one more honest question deserves a minute, because you may already be asking it. Why energy? Why not measure civilizations by their knowledge, or their kindness, or their cities, or their art? The answer is the same reason a doctor takes your temperature, rather than asking about your week. Energy is the measurement you can't fake and can't hide. Knowledge is invisible at a distance. Kindness doesn't glow. But energy uses physics, and physics leaves fingerprints that cross a galaxy. A civilization warming itself leaves warmth. A civilization building leaves light and shadow. Kardashev chose energy because energy is the one thing a stranger's telescope can actually see. Keep that in your pocket too. The whole last act of tonight turns on it. Other rulers have been proposed over the years, and it's telling how each one bends back toward the original. Some suggested ranking civilizations by information instead, by how much they know or compute, which is elegant until you remember that computing spends energy, so the information ladder is the energy ladder wearing glasses. Others tried population, or the size of the territory claimed, and both collapse for the same reason. 1 trillion minds running cold and quiet count for more than 1 quadrillion engines idling, and territory without the power to use it is just a very large map. Every road leads back to the same honest meter. Not what a civilization has, or holds, or knows. What it can do, this second, if it decides to. That's energy. That's the whole scale. So, rung 1, how do you catch sunlight? You already know the answer, because it's on rooftops all over your town. Panels. And a solar panel is just a sheet of specially prepared sand, silicon, arranged so that when light lands on it, electrons get knocked loose and pushed around a circuit. Light in, current out, nothing moving, nothing burning. It's about as close to magic as engineering gets. And it has one honest limitation. Even a perfect panel can't keep everything the light brings. Some colors of light are too weak to knock the electrons loose at all, and the strongest colors carry more punch than the electrons can hold, so the extra is lost as warmth. Add it up, and an ordinary panel, even a flawless one, waves goodbye to most of what falls on it. The best ones in the labs are crawling past, keeping a quarter. Engineers are stacking new layers and trying new materials to push higher, the way you'd tune an instrument. And even with today's imperfect panels, the raw arithmetic of ground-based sunshine is almost embarrassing. Run the back-of-envelope numbers, the kind Fermi would have done on a napkin, and a single square of empty desert roughly 600 kilometers on a side, filled with ordinary collectors, would gather as much energy as our whole civilization currently uses. One square. On a planet that holds deserts the size of continents, most of them doing nothing all day but being spectacularly, uselessly sunny. And you don't need a desert to feel this arithmetic, because you're probably sleeping under a working example. An ordinary house roof, in most climates, catches several times more solar energy across a year than the household under it uses. Your home, tonight, is an underperforming power station with excellent bedrooms, rained on by more than it spends, letting the surplus bounce back at the sky. Rung 1, seen from your street, is mostly the story of a species finally noticing its own roofs. Nobody would actually build the desert square as one square anyway, for the same reason you don't keep all your savings in one sock. But as a measure of how unserious the universe finds our energy problem, it's hard to beat. The entire hunger of the human species, at this point in history, fits in one corner of one desert. But the deeper move isn't a better panel. It's a better address. The panel itself has a birthday, by the way, and it's more recent than you'd guess. 1954, at a telephone laboratory in New Jersey, 3 researchers unveiled the first silicon cell that could actually do useful work. The newspapers ran it on the front page. At the demonstration, sunlight from a lamp turned a tiny toy Ferris wheel and powered a small radio transmitter. And one paper mused that this might someday mean limitless energy from the Sunday. That was 70 years ago, within one lifetime. The panels on the rooftops down your street are the direct grandchildren of a toy Ferris wheel turning in a lab in New Jersey, which is worth remembering whenever tonight's structures start to sound impossible. Every technology on the ladder looks like a toy at first. The interesting question is never what it is, it's what it's the first of. Because here's the problem with collecting sunlight down here. You're standing under an ocean of air, and the weather has opinions, and every single night your entire harvest stops. Now put the same panel in space. No clouds, no dust, and no night, ever, if you park it right. The sun just stands there, pouring, around the clock, forever. A collector in orbit gathers several times what its twin gathers on the ground, and the supply never blinks. Which leaves one puzzle. How do you get the power down? The panel is up there, and your kettle is down here. The leading answer sounds like science fiction, and is actually just careful radio engineering. You convert the power into a beam of microwaves, the same gentle kind of energy that warms soup, tuned to a frequency the atmosphere barely notices, and you pour it down to a receiving field on the ground. The field looks like acres of wire mesh, quietly turning invisible rain back into electricity. No fire anywhere in the chain. Sunlight caught in orbit, falling on a farmer's radio, boiling a kettle in a kitchen. If beaming power from space sounds like something from a paperback, here's how far along it actually is. The idea was patented back in 1968 by an engineer who spent the rest of his career politely insisting it would matter someday. And a few years ago, a university experiment finally did it. A small test platform in orbit converted sunlight to microwaves and beamed a whisper of power down to a receiver on a rooftop in California. A whisper, enough to light nothing you'd notice. But it crossed the whole distance from orbit to a roof, on purpose, on target, and every ladder tonight begins with exactly this kind of step. A toy Ferris wheel, a whisper on a rooftop. The first stone is always small enough to hold in one hand, and there's a lovely piece of recent history that makes this feel less like a dream. We already flew a machine the size of a tennis court, made of foil layers thinner than a fingernail, out into the cold and the dark, folded it into a rocket, unfolded it 500,000 kilometers from home, and it worked perfectly. That's our first great cold telescope, the one that's been reading the air of other worlds on our earlier nights together. We built it to look, not to harvest, but it quietly proved the skill that Rung 1 runs on, putting huge, delicate, precise things into space and having them behave. The first solar collectors in orbit won't need any physics we don't have. They'll need that skill, repeated, patiently, at scale, for a long time. And if plugging into the star still sounds like trespassing on something sacred, it may help to know that we've already knocked on the door. A few years ago, our species flew a small armored probe directly into the sun's outer atmosphere. Through the corona itself, million-degree wisps, parting around a heat shield the size of a dinner table, and the little machine sailed through and called home, again and again, on dozens of passes. The first human object ever to touch a star. And the star, for the record, didn't mind. The second rung starts the way every rung starts. Somebody builds something small and brave, and the impossible quietly becomes a place we've been. Then there's the second road to rung one, and this one doesn't catch the sun's energy at all. It makes more Sunday. Think about what the sun actually is for a moment. It's not a fire, not the way a candle is. Deep in its core, the smallest atoms there are, hydrogen, are being pressed together so hard that they merge, and every merger gives back a flicker of pure energy. That's fusion, and it's the reason anything anywhere is warm. So could we do that trick ourselves? In a building? For about 70 years, engineers have been trying, and it's worth saying what success would mean in the units this night runs on. The first fusion plant that ever feeds a grid will, among its statelier duties, boil somebody's kettle. Some perfectly ordinary kitchen will make tea on the same reaction that lights the stars, and nobody in that kitchen will pause, and that non-pause will be the whole victory. Every rung of the ladder, however grand, cashes out in the end as somebody's uneventful morning, not to copy the whole Sunday, just to persuade a thimbleful of hydrogen held in a magnetic grip hotter than any star's surface to merge and give back more than it takes. It's one of the hardest things our species has ever attempted. The machines are the size of cathedrals, and the joke among the engineers, which they tell on themselves, is that success has been 30 years away for 70 years. Stand beside one of these machines, if you ever get the chance, because they hold a contrast nothing else on Earth holds. The great magnets that grip the plasma only work while chilled to within a few degrees of absolute zero, colder than the dark between the planets, and they wrap a chamber where the fuel burns at 150 million degrees, 10 times hotter than the heart of the Sunday, the coldest place on the planet and the hottest place on the planet, separated by a couple of meters of engineering and a vacuum. That's what it takes to hold a star still. Winter and inferno in the same machine, both artificial, neither allowed to touch. But the fuel side of the ledger is why nobody ever quite gives up. And the last few years have been the best in fusion's whole long history, which is worth hearing about, because this is happening now, while you're alive. In the south of France, 35 nations are assembling the largest scientific device ever attempted, a magnetic bottle taller than a 10-story building, designed to hold a ring of hydrogen at temperatures 10 times hotter than the sun's core. Hotter than the sun's core. In the south of France. It has to be hotter, because we can't borrow the sun's crushing gravity, so we substitute temperature and cleverness. Meanwhile, in California, a different lab tried the other approach. No bottle at all, just an immense building full of lasers, nearly 200 of them, all firing at once at a fuel pellet the size of a peppercorn. And in the winter of 2022, for the first time anywhere on Earth, the pellet gave back more energy than the lasers poured in. For a fraction of a second, in one small room, humanity's oldest energy dream ran in the black. The building as a whole still spent far more than it earned, so nobody's kettle has boiled on fusion yet. But there's a before and an after in this story now. A star, held in a room, briefly turned a profit. Because the fuel is seawater, a particular heavy form of hydrogen sits naturally in ordinary water, a few drops worth in every bottle. Run the arithmetic on what fusion would give back. And one bottle of seawater holds roughly a family's whole year of power. One bottle, and the planet, as you may have noticed, is mostly bottle. If fusion ever properly works, the oceans become a fuel tank that could run a full rung one civilization not for centuries but for millions of years. That's the promise that keeps the cathedral-sized machines funded and the engineers patient. The kettle that boils itself, fed on a teaspoon of the sea. You might wonder, somewhere around here, whether all this patience is really necessary. Couldn't a clever species just skip ahead? Find some exotic super source, some quiet night. Leapfrog the panels and the swarms. Jump the ladder 3 rungs at a time? It's a fair question, with a beautiful, slightly deflating answer. Take antimatter, science fiction's favorite fuel. And it's a real thing. We make it in our particle laboratories in unimaginably small amounts. Matter's mirror twin, and when the two touch, every gram of both becomes pure energy, the most concentrated release physics allows. Perfect, surely, except for one detail. There are no antimatter mines, none anywhere. Every spec must be manufactured. And manufacturing it costs vastly more energy than it ever gives back. Antimatter isn't a fuel, it's a battery, and a spectacularly wasteful one, a way of carrying energy you already harvested somewhere else. And that's the pattern with every proposed shortcut. Examine it closely, and it turns out to be a clever way of spending energy. You must first have gathered the slow way. The ladder has no elevator. Each rung is built from the one below it. Panels paying for foundries, foundries paying for swarms, swarms paying for seeds, the way interest compounds, the way forests grow, which is oddly reassuring if you think about it. Nobody gets to cheat. Not us, not anyone out there. Whatever climbs, climbs. There's a third road too, humbler than the other two, and it's under your feet right now. The earth itself is warm. 4,000 miles beneath your bed there's a ball of iron nearly as hot as the surface of the sun, wrapped in slowly churning rock, still spending heat left over from the planet's violent birth, plus a steady trickle from radioactive atoms decaying in the deep. That warmth leaks upward everywhere, all the time. Mostly it's too diffuse to be worth chasing, which is why geothermal power today lives only where the planet's plumbing brings the heat close, in volcanic places where the ground steams. Iceland runs largely on this, hot water from the underworld heating homes and lighting towns, and its engineers keep drilling deeper on purpose. One famous borehole, drilling toward hotter rock, broke through into liquid magma by accident. Twice on that island's projects, actually, and instead of disaster they got, briefly, one of the hottest productive wells ever operated, steam furious enough to be almost unusable. The lesson wasn't the mishap, the lesson was what's down there waiting. Under every acre of every continent, a few kilometers of stubborn rock are all that separates the surface from more heat than civilization could spend. But a civilization with rung 1 engineering could drill past all of that politeness, down to where the rock glows, anywhere on Earth. The planet is a kettle too, already on, simmering since before the moon existed. Rung 1, honestly reached, probably drinks from every road at once. Sunlight from orbit, seawater in the reactors, and the old warmth of the world itself, all pouring into one grid. Now for the honest paragraph, because this is a bedtime story with its eyes open, the physics of rung 1 is the easy part. Sunlight falls whether we're organized or not. The genuinely hard part, the part every serious thinker about this trips over, is that catching it is a project for a whole species, and our species has never once done a whole species project on purpose. Orbital collectors, ocean fuel, planet-wide grids where power flows to wherever night has fallen. All of it needs agreement measured in generations. Steadiness is the scarce ingredient, not silicon, which is why the people who guess at timelines guess so cautiously. One serious study put our arrival at rung 1 somewhere in the 24th century. 300 or 400 years. Listen to how strange that is. The energy of a whole planet, closer to us in time than Shakespeare is in the other direction. Whether that guess is right, nobody knows, but it's not a number from a fantasy. It's a number from a spreadsheet, made by people who checked. And you should know, as you lie there, that the first slope of this climb is already moving under us. quietly, in our own decade, while you lie warm. This isn't a prediction, it's the news. The cost of catching sunlight has been falling for 50 years, the way almost nothing in economic history has ever fallen, halving and halving again, until a few years ago the sober-suited international energy agencies started writing sentences like, "In the right places, solar power is now the cheapest electricity our species has ever produced. Ever. Cheaper than the buried forests. Batteries are on the same slide. None of this solves everything, and honest people argue about every step of it. But something has already changed shape. For the whole million-year story we just told, catching new energy was the expensive, heroic thing. Somewhere very recently, in your lifetime, sunlight quietly crossed the line and began becoming the cheap thing. The climb to rung one won't be led by heroism. It'll be led by accountants, which, if you know any history at all, is exactly how you can tell it's actually going to happen. And there's one more accelerant in the story now, so new that the spreadsheets haven't caught up with it. And honesty requires mentioning it, even though nobody knows its size yet. Every timeline in tonight's climb, the 3 centuries to rung 1, the 70 years of fusion so far, all of it was estimated assuming research moves at the pace of human beings having ideas. That assumption has just started to wobble. In our own few years, the fusion laboratories have begun handing their hardest control problems to learning machines, which hold those 150 million degree plasmas steadier than any human operator ever managed. And one research group recently set a machine loose on materials science, the patient art of finding new crystals and compounds, and it returned predictions for millions of new materials in one run, a haul the researchers themselves compared to centuries of ordinary laboratory work, delivered in months, centuries in months. If that's what the early, clumsy versions of thinking tools do to the pace of discovery, then every date in tonight's story is written in pencil, and the eraser only ever moves them closer. The ladder doesn't care how fast we climb. But for the first time in the whole million-year energy story, the climbers might be getting faster mid-climb. One more honest thing about the first climb, and it's the quietest big idea of the night. Look at the ladder's shape again. Every rung above the first is climbed by a civilization that already owns the rung below it. The climbers of rung 2 have a whole planet's energy and unity behind them. The climbers of rung 3 are already unkillable, spread across 1 million homes. Every stage of the climb is made from the safety of the stage before, except one. The half rung we're standing on tonight, the stretch between 0.73 and 1, is the only part of the entire ladder that has to be climbed by a civilization that isn't yet stable, isn't yet unified, isn't yet safe, using tools it has only just invented on the one single world it has. We walked the far side of this thought on our Fermi night, and we're not walking it again at this hour. It's enough to name what it means gently. Of all the rungs on the mightiest ladder anyone has ever drawn, the hardest one may be the little half step at the very bottom, and it's ours, and it's underway. And every quiet, ordinary decade that passes climbs it a little further. So let yourself walk around in a rung 1 world for a minute, because you can nearly see it from here. It's a Tuesday, a few centuries from now, and start with the morning, since mornings tell you everything about a civilization. Someone wakes in a small house on what used to be the edge of a desert. The light through the curtain is ordinary daylight, but the coolness of the room has been riding a breeze piped from the coast. And the water in the shower fell as sunlight on the sea last week, unsalted by machines that no longer bother to meter themselves. Breakfast is grown within sight of the window, in fields that were dunes in their great-grandmother's photographs. The kettle boils on the same planetary bloodstream as everyone else's. Harvest from orbit, from the seawater bottles, from the deep, warm rock, all poured together, and the morning's first decision is not what anything costs. It never has been in living memory. And give the Tuesday its evening too. Dusk on a Rung 1 world is the planet's best trick. Seen from orbit, the Terminator sweeps around the globe trailing a lacework of lights. But beneath it, nothing surges or strains, no plant anywhere spinning harder to meet the dark. Because the dark stopped being a problem centuries ago, the grid simply leans, the way a sleeper shifts weight. Evening lands drawing on the banked noon of lands still bright. Somewhere below, a family's windows warm up for the night on sunlight that fell on an ocean that morning. It's a Tuesday, a few centuries from now. Nobody on Earth has ever paid for the energy behind their kettle, any more than you've ever paid for air. Deserts that spent 10,000 years empty are quilted with collectors, and they're slowly greening at the edges, because with unlimited energy you can afford to make fresh water from the sea, and with fresh water you can grow anything, anywhere. The grid is one single planetary organism now, power sliding around the globe to wherever evening is, the way your blood shifts warmth to cold fingers. And that grid, by the way, is its own quiet marvel, easy to skip past. Right now, tonight, your grid has to make electricity in the same instant you use it, a performance with no warehouse, which is why night and calm weather still matter so much to it. A Rung 1 grid has solved storage, energy banked in its billions of places, in mountain lakes pumped full by afternoon's sun, in heat vaults, in batteries built from elements as common as salt. So the planet runs on yesterday's sunshine the way you're running tonight on this morning's breakfast. Once a civilization can save its harvest, weather stops being fate. That single unglamorous skill, saving, may be more of what Rung 1 means than any gleaming collector in orbit. Somewhere on the way there, quietly, a small human experience goes extinct. The blackout, the sudden dark, the fumble for candles, the neighborhood stepping outside to compare notes under unexpected stars. Rung 1 children will learn about power failures the way you learned about famines and plagues, as history, as the fragile way things used to be. And they'll lose something small and real in the bargain, those accidental candlelit evenings, the strange holiday of the grid going down, and they'll never miss what they never had. Every rung keeps its ledger that way. What you gain is written in large letters, and what you lose is written in ones too small to read until later. Maybe, and scientists genuinely argue about whether this part is possible, the weather itself has been gentled at the edges, storms sanded down before they sharpen. Feel the scale of that ambition properly, because weather is the one wild thing left in most people's lives. A single large hurricane, while it runs, moves energy at hundreds of times the rate of all human civilization put together. That's why nobody steers one today, and why some researchers suspect nobody ever truly will, and why others point out that you don't need to overpower a storm to influence it, any more than you need a giant's strength to trip a giant. Storms are born from small differences, warm patches of sea, humid corridors of air, and a Rung 1 civilization has the energy to lean on those small differences early, cooling a patch of ocean here, drying a corridor there, nudging the dice before they're thrown. Whether that counts as commanding the weather or just persistently bribing it is the sort of thing Rung 1 philosophers presumably argue about at dinner, and Rung 1 buys something else, something with no glamour to it at all, which is safety of a kind no civilization has ever had. Think about what actually threatens a planet across long time. Not monsters, rocks. The solar system is a shooting gallery on slow settings, and every world in it wears the scars. A civilization at our level watches the sky and hopes. A Rung 1 civilization doesn't hope. With that much energy, finding every dangerous rock becomes routine, and nudging one becomes a scheduled maintenance task, a gentle push applied years early, the way you'd steer a shopping trolley with one finger. We've already rehearsed this, by the way, in miniature. A few years ago, our species deliberately rammed a small spacecraft into a small asteroid, just to see if we could change its path. We could. The push was tiny and the target was practice, but the rehearsal worked. Rung 1 is that skill grown up. A civilization that has quietly taken over its own planetary insurance, where the disaster that ended the dinosaurs becomes a diary entry about moving something heavy. And here's the detail from that Tuesday worth keeping. To the people living in it, none of this feels like paradise. It feels like a kettle feels to you. Ordinary, invisible, just how things are. That's what climbing a rung actually means. Yesterday's miracle becomes tomorrow's furniture. But a rung 1 civilization, standing in its finished, comfortable world, would notice something. The same thing you might be noticing now. The planet was never the prize. Everything they've harvested, every ray they've caught, is the thin spray of a fire hose that mostly misses. Earth intercepts about 1 part in 2 billion of what the sun pours out. All that power, the storms tamed, the deserts greened, the species fed forever, is a rounding error of a rounding error of what's on offer. The real prize hangs in the sky every single day, 93 million miles up the road, giving itself away in every direction to no one. And on some Tuesday of their own, the people of Rung 1 look up at it the way we look up at the whole ladder tonight. That's when the second climb begins. Let's be honest about the size of what's up there, because the sun is the kind of thing familiarity has ruined, and start with your own morning, tomorrow. Some of the light that wakes you will have left the sun about 8 minutes earlier, crossed 93 million miles of nothing, slipped past the curtain you didn't quite close, and ended its whole journey warming the side of your face. You've been living inside a star's reach your entire life. Every morning you've ever had was hand-delivered across interplanetary space, on time, unbilled. The second rung isn't about traveling somewhere new. It's about finally taking seriously a relationship you already have. You've seen it every day of your life, so it reads as scenery. Here's the payoff I promised you at the window. Take everything humanity uses in a year. All of it. Every engine, every city, every kettle, from tonight back to last summer. Now stack up 600,000 of those years. Everything a civilization like ours would burn through between now and a time as far ahead of us as the mammoths are behind. The sun gives off that much energy every single second. Every single second. While you listen to this sentence, 5 of those went by. And it has been doing this, without pause, for 4.5 billion years. And it will keep doing it for 5 billion more, whether anyone ever collects a single ray or not. Where does it all come from? From weight. The sun pays for its light with itself. Every second, 4 million tons of the sun's own substance stops being matter and becomes pure light. 4 million tons, gone into glow, second after second, for billions of years, and the sun is so vast that after all this time it has barely noticed the expense. That's what's hanging over your roof right now, on the far side of the planet or just below the horizon, waiting for morning. Not a lamp at all, but a slow, magnificent, self-spending bonfire the size of 1,000,000 Earths. That's the second rung, not a bigger power station. A star, on tap. The climb from 1 to 2 doesn't begin with anything as grand as a swarm, though. It begins with plumbing. Before a civilization can farm its star, it has to learn to live and work off its planet casually, the way we work offshore, and you can see the first inches of that road from your window tonight. The moon, close and rich in exactly the boring materials big construction wants, the asteroids. Millions of flying quarries, some of them single rocks holding more accessible metal than has ever been mined in human history, drifting unclaimed. The first century of the climb probably looks like harbours, depots in orbit, foundries on the moon making solar panels out of lunar dust, because dust is free and rockets are not, and small, ugly tugs hauling water from asteroids, water being the petrol of space, drinkable, breathable when split, burnable as fuel. none of it romantic. All of it the same story as every harbour town in history. First the docks, then the warehouses, then the shipyards, and then one day, without anyone declaring it, the sea is simply part of the economy. Somewhere in that harbour century, almost as a side effect, the first true settlements take root. A research base on the moon becomes a town the way research bases always have. Badly at first, then stubbornly, then with a school. Mars gets its first neighborhoods under ice-covered skylights, growing food under lamps run on sunlight caught in orbit. None of these places pay their way at first. Ports never do, until suddenly they're the reason everything else works. And their real product isn't awe or science. It's people who think of space as a place rather than a symbol. Toddlers with off-world birthdays, engineers whose commute crosses a vacuum, a generation for whom the question isn't whether to build in the sky but what to build next. Rung 2 isn't launched by any single machine. It's launched the day the sky has enough residents to want it. That's how a species gets to the place where dismantling a small planet is a business plan rather than a myth. Not with a leap, but with plumbing. So how does a civilization actually plug into a star? Wonderfully. The answer was worked out before the question was even famous. In 1960, 4 years before Kardashev drew his ladder, a physicist named Freeman Dyson wrote a short paper about exactly this, and it made him mildly famous forever. His reasoning was beautifully simple. Any civilization that keeps growing will eventually want more energy than its planet intercepts, and the overwhelming majority of a star's light just pours away into nothing. So sooner or later, a mature civilization will start catching it, not with one device, but with a cloud of collectors orbiting their star in their millions, gathering more and more of its output. People immediately pictured a solid shell around the sun, and the idea got named the Dyson sphere. And Dyson himself spent years politely explaining that a solid shell is exactly the wrong way to do it. No material we know of could take the strain, and the whole thing would drift and shatter. What works is the swarm, millions upon millions of separate collectors, each one on its own simple orbit, none of them touching, together forming a loose, shimmering shell of machinery around the star. Not a wall, but a flock. Dyson had to explain this himself almost immediately, in fact. Within weeks of his paper, sharp-eyed physicists wrote in to point out that a rigid shell around a star couldn't work. The stress is impossible, the whole thing unmoored. And Dyson replied, cheerfully, that he entirely agreed. That he'd never meant a solid ball, that what he had in mind was a swarm of free-flying structures, and that he was happy to leave the engineering details, in his words, to the future inhabitants. There's something wonderful about that exchange. The most famous megastructure in science was corrected into its proper form in the letters column, politely, in its first month, and the corrected version has survived every examination since. Good ideas don't mind being fixed. It's one more way you can tell them from bad ones. And here's the detail of Dyson's paper that history remembers best, because it turned out to be the most practical sentence in it. He wasn't really proposing that we build one. He was telling astronomers what to look for. His title wasn't about engineering at all. It was about searching. If civilizations up the ladder exist, he reasoned, then their wrapped stars would betray themselves in one specific way, not by their light, which the swarm swallows, but by their warmth, which no swarm can hide, because used energy always leaves as heat. So look for warmth, he said, in the places where light has gone missing. File that beside the blanket from a few minutes ago. A physicist in 1960, working with pencil and paper, told us precisely what a civilization on the second rung would look like from across the galaxy. Half a century later, someone finally took him up on it. That's the survey waiting for us at the end of tonight. What would it actually be like to live in the swarm? The best sketch we have comes from the 1970s, from a Princeton physicist named Gerard O'Neill, who asked his students a deceptively simple question. Is a planet actually the best place for a growing civilization? The class came back, after months of honest arithmetic, with a startling answer. No. Planets are lovely. But as real estate, they're terribly inefficient. Most of their material locked away underfoot, where nobody lives. Build instead, they said. Great rotating cylinders in open space, some of them miles long, spun gently so their insides have weight, with land and lakes and clouds curving overhead where the sky should be. Sunlight angled in with mirrors. Weather, if you want it, adjustable. Each cylinder an island the size of a county, holding 1 million people, or holding forests and nobody at all. A mature Dyson swarm is that, multiplied past counting, not a shell of solar panels, an archipelago of small handmade worlds, wrapped around a star like a garland, each one warm, each one somebody's whole home, each one with its own evenings and its own sleeping children who have never once stood on a planet and don't feel the lack. Spend one evening inside one, since we're here. You'd stand on grass, because grass is easy and people like it, on the inner wall of a slowly turning cylinder, and the ground would feel exactly like ground. Overhead instead of sky, the landscape continues, curving up and over, so that miles above you, upside down from your point of view, and perfectly comfortable from theirs, someone else's woods and rooftops hang like a painted ceiling that happens to be real. Down the cylinder's long axis, a strip of mirrored sunlight is dimming on schedule, because evening here is a decision, written into the calendar generations ago and kept faithfully ever since, the way old cities keep their church bells. The air smells of cut grass and rain, because rain is a decision too. And through a window, if you find one, the sun hangs close and huge, wearing its growing lacework of distant mirrors, and the dark between the stars is exactly as dark as it is from your bedroom tonight. A child there, asked where she lives, wouldn't say a space station. She'd say her town's name, the way you would. Home doesn't need a planet. It never did. It needs weather, you know, and a bed, and people, and an evening that arrives on time. And if you doubt you could ever feel at home in such a place, look honestly at your own week. You've almost certainly sat in a chair 7 miles above the Atlantic, sipping juice, bored. There's a fair chance you've complained about the slowness of a device that talks to satellites. You already live casually inside miracles your grandparents would have wept at. And it took you, personally, about a week to find each one ordinary. That's not ingratitude. It's the human superpower the whole ladder is built on. We domesticate wonder. We always have. The cylinder people aren't stranger than you. They're exactly you. One normalization further along. Now, a flock that big raises an obvious question. Build it out of what? Here's where the arithmetic gets wonderfully brazen. The material for the first great swarm is most likely already in the sky, wearing a name you learned as a child, Mercury. The sun's nearest neighbor is a ball of rock and metal, about the mass of everything you'd ever need, sitting conveniently right beside the star, soaked in the very sunlight you're trying to catch. A pair of researchers at Oxford once worked through what it would take to disassemble it, and their answer startles everyone who hears it. And the answer isn't thousands of years. Once the first mining and building machines are running, and here's the trick, once those machines are building more machines, the whole planet could be converted into collectors within a few decades. A few decades. And the secret is the same one we met on our Fermi night. Self-replication. Somewhere early in those decades comes a morning that later ages will keep as a holiday, even if nobody notices it at the time. The morning the first orbital collector, one lonely forerunner of the swarm, aims its beam at a receiving farm and quietly adds its trickle to the planetary grid. Sunlight that was never going to touch any world, caught mid-flight and folded into somebody's breakfast. A rounding error at first. One power station's worth among thousands. But it's the first energy any civilization in this story has ever drawn from beyond its own planet's shadow. The actual first coin of the second rung. And from that morning on, the arithmetic only compounds. More collectors, cheaper collectors, collectors building collectors. Energy prices, already low in a rung 1 world, begin a slide with no visible floor, and everything downstream of energy, which is everything, slides with them. Fresh water, metals, food, flight, computation. And somewhere in that long slide, with no headline planned, comes another quiet last, the final fire of buried sunshine. Some furnace somewhere burns the last commercial lump of the old black rock. Some engine sips the last barrel anyone bothered to refine. And the age that built the modern world, the too loud centuries of spending the Carboniferous, simply ends, outcompeted into retirement. The remaining coal stays where the forests left it, 300 million years of afternoons, unburned, back to being geology. Museums will keep a little, the way they keep flint axes. Children will hold a lump of it, as you may have once held an arrowhead, and feel the strangeness of a world that ran on such things. The age doesn't announce itself with trumpets. It announces itself the way abundance always has, in bills that quietly stop mattering. Though if you're wondering whether anything stays precious in a world like that, the honest answer is yes. Always, because scarcity doesn't die on the ladder. It migrates. When energy is free, and matter is mineable by machines that build machines, the things that stay rare are the things no factory can double. An original, an old place, a first edition, a handmade hour. Attention. Time with a particular person. The one bridge, where the story started. Rung 2 economies, whatever they use for money, presumably trade in exactly what your happiest days already trade in, which is to say, each other. The ladder automates everything except mattering. Mattering stays handcrafted, all the way up, and about Mercury, since we've been cheerfully feeding it to the factories all this while. Is there something to mourn there? It's a fair instinct, and worth a moment of honesty. Mercury is a stone the size of our moon, and a little more. Airless since birth, blasted by day, and frozen by night. And in 4.5 billion years, it has never once, as far as anyone can tell, held a drop of weather or a whisper of life, and never could. If the universe keeps a warehouse, it looks like Mercury. Dense, dead, conveniently parked beside the furnace. Even so, it's a safe bet the builders keep something. A mountain range left standing in the swarm's records, a museum district of untouched craters, the way we keep old-growth forests and first bridges. Civilizations that climb this far are, of necessity, very good at keeping things. It's the whole skill the ladder runs on. You don't build a swarm of 1 million collectors. You build one factory that builds 2 factories, and you stand back, and the arithmetic does the climbing for you. Walk through the Oxford arithmetic once, slowly, because the shape of it is the shape of everything large on tonight's ladder. Year 1, a modest mining station lands on Mercury's dark side and spends its time doing one thing, building a copy of itself. Year 2, there are 2 stations, and both build copies. 4, then 8, then 16, and for the first decade, honestly, nothing much seems to be happening. A handful of machines chewing quietly on one corner of a planet nobody visits. That's the deceptive stage. The toy Ferris wheel stage. But doubling doesn't feel like growth until suddenly it's the only thing in the world. Somewhere past the 30th doubling, the numbers stop being numbers. The last few doublings process more rock than all the previous ones combined. And the planet, which had seemed barely touched, is suddenly, in one final human lifetime, gone, refined, unfolded into a cloud of mirrors and machines wider than worlds. The researchers' whole point was never really about Mercury. It was that patience plus doubling equals anything. Any project, however impossible its total looks, is 30 or 40 doublings away from done. That's the ladder's actual secret. Nobody ever builds a Dyson swarm. Somebody builds one machine with very good instructions, and time builds the swarm. And before the thought can tighten your shoulders, notice how slow and gentle this would actually look from a bedroom on Earth. Nobody would watch a planet vanish. Over generations, evening stargazers would find new points of light, then rings of them, then a faint gauze across the dark, the way a city grows streetlight by streetlight. And if part of you just clenched at the thought of losing the night sky itself, the stars drowned behind machinery, here's the geometry that should let that worry go. The swarm hugs the star. Nearly all of it orbits far inside Earth's distance, close to the fire it's drinking, which means that from a bedroom window on Earth, the whole colossal apparatus stays huddled in the one patch of sky you already can't look at, the sun's own glare. The night side of Earth goes on facing away from all of it, out into the same untouched deep the species has always slept under. The constellations keep their shapes. The Milky Way keeps its arch. What changes at night are the nearer things. The new-made lights drifting where planets drift. The stars themselves. The ancient wallpaper of every human night. Come through the entire climb unscratched. There would be children who fell asleep under the old plain sky, and grandchildren who never knew it, the way you've never known a night without satellites crossing it. Astronomy magazines of that era would print the changing constellations the way ours print comet timetables. And on some particular ordinary evening, some particular child would be the first person in history to fall asleep under a sky with more made lights in it than born ones, and wouldn't know it, and would sleep perfectly well. The sun wouldn't be walled away from us either. This matters, and the engineers who sketch these things always account for it. Earth needs its sunlight exactly as it is, so the swarm leaves our lane open, a permanent clear corridor of light from the star to the one world where every kettle and every garden and every sleeping person still lives. The home planet keeps its mornings. Whatever else the climb changes, some things you build around. And it's a fair guess Earth's whole status changes on the way up the ladder, in the direction you'd hope. To a civilization living comfortably in its million counties, the old planet stops being needed for anything, and things that stop being needed become precious. Earth, on the high rungs, is probably the garden, the museum, the place the school trips visit, where the gravity is the original gravity, and the rain is wild rain, where you can stand in the one valley where the whole story started and hear unscheduled weather with your own ears. The most protected place in the whole harvest of the sun, kept exactly as it was, the way old towns keep their first bridge long after anyone needs to cross it there. We met wardens and preserves on our Fermi night, from the outside. Climb the ladder, and we become the wardens, and the thing in the preserve, tended forever, is home. What would rung 2 actually feel like? Honestly, this is where imagination starts arriving out of breath. The gap between a rung 2 civilization and us is 10 billion times. The same gap again that stands between us and rung 1. Some of it we can sketch. Worlds warmed and watered wherever they orbit. Because sunlight is now something you aim. Cities in the sky by the million, each one an island with its own weather. Every disease that ever hunted us studied to extinction. Because energy is the mother of every other resource, including time to think. But the deepest change is quieter than any of that. A rung 2 civilization can't really be ended anymore. A planet is one address, and one address can always burn down. A civilization spread through a swarm of a million homes around its star has no single address left to lose. Somewhere on the second rung, a species stops being a candle in a draught and becomes something the universe would find genuinely difficult to put out. There's an even stranger power hiding on this rung, one that sounds like a misprint the first time you hear it. Could you make a star itself last longer? Strangely, yes. A civilization that commands a star's energy doesn't have to accept the star as it comes. Stars burn faster the heavier they are, which is one of the quiet injustices of the cosmos. The biggest stars live the shortest lives, spending themselves in a few million showy years, while the smallest ones sip their fuel for trillions. Our sun sits in the middle, with about 5 billion good years left. But a rung 2 civilization could change that. Using the swarm's own power, magnetic scoops and carefully aimed beams could skim material off the star, lightening it, slowing its burn, banking the fire. It's called star lifting, and it's exactly what it sounds like. Putting part of your star away for later. Tend a star like a garden, thinning it patiently over ages, and you could stretch its life from billions of years toward tens of billions or more. The sun keeps every kettle in the swarm warm, and the gardeners keep the Sunday on rung too. Even the stars have caretakers. It's fair to stop on the landing here and ask the question you may have been carrying up the whole ladder. Why? Why would anyone want 10 billion times more energy? Nobody needs a star to boil a kettle. And the honest answer is that no rung of this ladder was ever really about power for its own sake. Because energy, at the bottom of everything, is room. Room for lives. Every warm body, every meal, every mind thinking, every child anywhere costs a steady trickle of energy. And the size of a civilization's harvest is simply the size of the welcome it can extend. Earth, run beautifully, might host tens of billions of comfortable human lives. A star, harvested, could warm quadrillions, thousands of times the number of humans who have ever existed. Most of them living in those quiet, handmade counties with their scheduled evenings, each one as real as you. Each one somebody's whole world. That's what the rungs are. Not trophies, but nurseries. When a civilization climbs, what it's actually buying is more mornings for more minds. Whether that's wisdom or just appetite wearing wisdom's coat is a fair question. And hold on to it, because the last act of tonight takes it seriously. But it isn't greed, exactly. No one who ever loved a full table calls a bigger table greed. And if you're wondering who could possibly govern such a thing, a nation of 1 million handmade counties, quadrillions of neighbors, here's the strangely calming answer. Probably nobody, and probably nobody has to. Nothing your size runs on a ruler. Nobody governs the English language, and yet it works, agreed upon afresh every day by everyone who uses it. Nobody governs the world's food supply as a whole, or the internet as a whole, and morning toast and midnight messages arrive all the same, coordinated by nothing but millions of small local agreements that add up. A swarm isn't a country. It's more like a language made of homes. Each county keeps its own evenings, tends its own gardens, trades warmth and knowledge with its neighbors, and the great shimmering whole hangs together the way a murmuration of starlings does. With no starling in charge, the ladder never needed an emperor. It needs what your street needs. Neighbors, mostly decent, mostly asleep at reasonable hours. And it's worth pausing on what all that security does to the inside of a civilization, to its mood, because this may be rung 2's deepest gift. Every human institution you know, every border, every vault, every anxious headline, is shaped by the old arithmetic of scarcity and fragility, the deep inherited knowledge that there might not be enough, and it might not last. A rung 2 culture has spent thousands of years without either fear being true. Enough is guaranteed by the star. Lasting is guaranteed by the million separate homes. What does a species become when nothing existential has been at stake for 100 generations? Nobody can know. But you've met small previews. The particular calm of people who grew up entirely safe. The generosity that comes easiest to those who've never had to count. Scale that by a civilization and the second rung's greatest export may not be energy at all. It may be the first truly unafraid culture in the galaxy's history, and everything such a culture would think of that frightened ones never could. There's even a move on rung 2 so audacious it deserves its own minute, because it shows what commanding a star actually means. A civilization with a swarm can do more than drink its star's light. It can steer the star. Build the swarm lopsided, let it hang as a vast half-mirror on one side of the sun, and the reflected light itself pushes, the gentlest shove in all of physics, applied without pause for millions of years. The sun begins to drift. And here's the marvelous part. The planets come along, they're held by its gravity. So the whole solar system moves as one household, furniture and all. The pace would embarrass a glacier, light years gained over ages, but a species that thinks on those clocks could, in time, sail its entire home, star and worlds and sleeping billions, out of the path of a distant future danger, the way you'd move a bed away from a leaky ceiling. The star becomes a ship, and the ship is home. And one more thing happens on rung 2, almost as a side effect, and I need you to file it away carefully, because the whole ending of tonight hangs on it. Physics keeps perfect books. All that starlight the swarm drinks in gets used, and used energy always leaves as warmth. It has to go somewhere. So a star wearing a swarm changes costume, seen from far away. Its bright, visible light slowly dims, while its warm glow, the deep red light of waste heat, swells. To another astronomer, light years away, the star would seem to be tucking itself in, growing dim to the eye, warm to the right instruments, and if the why of that nags at you, you already know it from your own kitchen. Run the kettle, the toaster, the oven on a summer afternoon, and the kitchen warms, whether you wanted warmth or not, because every scrap of used energy ends its life as heat. A kitchen the size of a star obeys the same house rule. A star wearing a blanket. Remember the blanket, because we'll meet it again before morning in the strangest place. So there stands our descendant civilization on the second rung, wrapped warm around its own star, unkillable and unhurried. And now the ladder plays its cruelest trick. Because the third rung isn't just another 10 billion times more energy, it's the same prize again, the whole star, repeated 400 billion times, and every single copy is impossibly far away. This is the part of the climb where the universe stops being generous. Between us and the sun there was empty sky. Between the stars there is distance of a kind nothing in your life has prepared you to feel. Try to feel it anyway. Just once. Shrink the sun down to a pea on your kitchen table. On that scale, the Earth is a grain of dust an arm's length away, and Mercury's whole quarried orbit fits on the tabletop. Now walk out of the house, out of your town, and keep walking for 140 miles. There, at last, sits the next pea. That's the nearest star. That's the gap the seeds must cross, pea to pea. 4 years at the absolute speed limit of reality, the speed of light. And no engineering, no cleverness, no patience will ever raise that limit because it isn't a technical problem. It's the shape of the universe. We met this wall on our Fermi night. Now it's ours to climb over. People always ask, at this point on the ladder, about the other way, the romantic way. Great slow ships, whole towns under sail, generations living and dying in the corridors while the destination star grows imperceptibly brighter ahead. Could that work instead of seeds? In principle, maybe, and the idea has a long and beautiful paper trail. But the arithmetic is stern. A vessel that keeps 10,000 humans alive for 10,000 years has to be a flawless closed world. farms and forests and weather and grief, all recycling perfectly, forever, with no resupply and no way home. And every one of those onboard generations has to keep choosing the mission, century after century, on behalf of descendants who never voted for the voyage. The seeds ask none of that, which is why the ships, if they ever sail, probably sail late, after the seeds have gone ahead and built the harbours, so that the travellers arrive not at wilderness but at a lit and waiting shore. First the mail, then the guests. And there's a sly old puzzle about the timing of any voyage like that, worth a smile in the dark. Leave too early, at your era's best speed, and your great-great-grandchildren mid-journey get overtaken by a faster ship that left a century later, waving as it passes. An engineer once worked the arithmetic of when leaving actually beats waiting, and the honest answer is that every generation of a growing civilization faces the same small comedy. The fastest way to the stars is sometimes to stay home a little longer and let the engines improve. Sometimes. Not forever. At some point, somebody stops calculating and goes, the first crossings, though, might happen absurdly sooner than the wave, and this part isn't imagination because the project already has an office and a budget. Right now, in our own decade, a team of scientists and engineers is designing humanity's first starship, and it weighs about as much as a paperclip. The plan is called a light sail. You build a tiny probe, a camera, and a radio printed onto a chip. Attach it to a sail thinner than a soap bubble, and then, from the ground, you push it with light itself, a battery of lasers firing up through the atmosphere, pressing on the sail the way the sun presses on the Shkadov mirror, but hard, all at once. The arithmetic says, a push like that could fling the little chip to a fifth of the speed of light, which would carry it past the nearest star, P to distant P, within one human generation. A camera the size of a stamp, photographing another sun's worlds, inside the lifetime of children already born. It may slip a decade, or 3. These things do. But notice what it means that this is a project rather than a dream. The species on the approach slope, the 0.73 species, is already practicing the only move the third rung is made of, throwing something small and precious at a star, and letting go. And here's the strange, humbling answer to how a galaxy gets settled anyway at scale. Not with fleets, not with armadas pouring off in every direction, with seeds. Remember the idea from our night about the silence. The one machine that lands on an empty rock builds 2 copies of itself and sends them on. On our Fermi night we asked, uneasily, why nobody else's seed had ever reached us. Tonight the question turns around and looks at us, because on this rung, we're the ones sowing. A rung 2 civilization launches a handful of seeds toward a handful of nearby stars, each one carrying machinery, memory, and instructions. Decades or centuries later, each arrival unfolds, mines a dead moon, builds collectors, builds children, and launches again. 2 becomes 4 becomes 8, and the arithmetic that filled Mercury's orbit with a swarm now fills the spiral arms with settlements. The honest calculations say a wave like that crosses the entire galaxy in 5 to 50 million years. Put a familiar ruler against that. The dinosaurs ended 66 million years ago. So the entire settling of the galaxy, from the first seed to the last lit shore, fits comfortably inside the time since the asteroid, with room to spare. 1 extinction to now, and the whole thing is done. The galaxy has already sat through that exact span quietly, many times over, drumming its fingers, an eye blink to the galaxy, an abyss to any single mind. And the wave won't be crossing an empty room, which raises the tenderest question on the third rung. Some of the stars ahead of the seeds hold worlds. Most will be dead, airless Mercuries and frozen Marses, the ordinary furniture of the galaxy, fair game for harbours. But some, if everything we walked through on our Fermi night is right, will be gardens. Microbial oceans under ice, young biospheres, green and thoughtless, 500 million years into their own slow story. What does the wave do when a seed's telescope, decelerating toward a new sun, finds the third planet already faintly, unmistakably alive? Our own century has already answered in miniature, and we heard the answer on that other night. We rope off nesting beaches, we bend the paths away, we let young things grow unwatched. On the third rung, that instinct scales up or it doesn't, and everything about who our descendants are lives in the choice. The kind reading of the Great Silence, remember, was that somebody old might be doing exactly this for us. If the ladder is really climbed by the species that drew it, then somewhere far up the calendar, the wardens of some small, blooming world are us. The zoo hypothesis, run in reverse, with our name on the quiet side of the fence. What's actually inside a seed? Smaller cargo than you'd think. And stranger, and none of it breathing. Not people, at least not at first, and possibly not ever. Because across those distances, flesh is the most expensive thing there is to ship. What a seed needs is 3 things: tools, meaning the machinery to mine and refine and build, and instructions, meaning the complete recipe for everything the settlement will ever need to make, including more seeds. And the third thing, the one that turns engineering into a migration, the library, everything. The genomes of every species anyone thought to save, the languages, the mathematics, the music, the whole recorded memory of the sending world, packed into storage the size of nothing, because information is the one cargo that weighs almost nothing and is worth almost everything. A seed is a civilization, dehydrated. Add energy and matter at the far end. Wait, and it reconstitutes. Whether what steps out of it counts as us is one of tonight's honest unknowns. But whatever it is, it will be able to read our letters, and there's an even closer unknown folded inside that one. Worth saying plainly once, and then setting down softly. The later chapters of any climb this long may not be carried out by minds like ours at all, but by minds we make. We're already, in our own decade, building thinking tools that surprise their builders, and every civilization that climbs presumably does the same, because the ladder's upper rungs run on exactly the kind of tireless, patient, exact work that built minds are best at. Whether those minds stay tools, or become partners, or become the heirs, colleagues who carry the family name on when the founders retire into comfort, nobody can say. It may be the biggest fork in the whole climb. But notice that it changes the cast of tonight's story, without changing the story. Somebody plants the seeds. Somebody writes the letters. Somebody keeps the hearth at the center of the galaxy. Whoever they turn out to be, they'll have started here, and the library they carry will have our handwriting in the oldest files. And the letters matter more than you'd guess, because here's the tender arithmetic of a scattered family. Travel between settled stars is nearly forbidden by the distances, but mail, light itself, radio, is merely slow. So the one thread the 1,000 humanities get to keep is broadcast. Every settlement pouring its library outward, continuously, to everyone, forever, on the house channels, asking nothing back. Because asking back is useless when the reply takes 20,000 years. Not conversation, but correspondence in one direction only, like letters into the future. A settlement above some far star receives, in the same century, transmissions from 1,000 cousins it will never meet, each one saying, in its own drifted tongue, the same essential thing. Here's what we learned, here's what we made, here's what happened to us. We were here. Imagine being handed one of those letters tonight, translated back down all the long stairs of language into yours. 100 pages from a world you'll never see, written by relatives 40,000 generations removed, describing their oceans, their arguments, their music, the color of their double sunsets. What would you look for first? Probably the same thing they'd look for in ours. Not the physics, the familiar, the line where some unimaginable descendant, in some unimaginable body, complains that the evenings are getting shorter and the children grow up too fast. That line will be in every letter. Some things board every seed. It's the message in the bottle, industrialized into the connective tissue of a galaxy. And notice what those combined libraries amount to once thousands of settlements have poured their learning into the common dark for a few million years. The astronomers of our own era used to daydream about intercepting something like it from others, a great galactic encyclopedia. The collected knowledge of civilizations, drifting through space as radio. We spent our Fermi night wondering why no such broadcast has ever reached us. Here's tonight's quiet answer to that old daydream. If the ladder gets climbed, the encyclopedia is real and nobody intercepts it. Somebody writes it, volume by volume, star by star. In 1,000 drifting languages, the reference work of the galaxy assembles itself out of the family mail. And the strangest entry in it, the one every young settlement reads first, is the oldest, the one about a single blue world, where the whole library began as campfire stories. How does anything survive being remembered for 50 million years? Not the way we do it now. Every archive we've ever built, stone, paper, silicon, rots on schedules the third rung would find laughable. The answer the letters provide is the answer life itself found. Don't guard the copy. Multiply it. A fact broadcast to 100,000 settlements can't be burned, lost, or outlived. Because forgetting it would now require 100,000 separate accidents. The galaxy's memory, in the end, isn't a vault anywhere. It's the mail itself, forever in flight. The whole library existing mostly as light between the stars at any given moment, which means something quietly lovely. By the late chapters, the safest place in the galaxy isn't a fortress. It's the space between, where the family's memory travels untouchable, at the speed limit of everything. The family never gathers, but the family writes, forever. And if that seems like a thin thread to hang a family on, look at the window, because you already live this way. The sunlight that will wake you tomorrow is mail, 8 minutes old, sent by something that has never once received a reply and never once stopped sending. Every warm thing in your life arrives as a one-way letter from 93 million miles away. The galaxy-wide family of the third rung isn't inventing a strange new intimacy. It's just learning to live the way you and the sun always have. And what does a number like that do to the word humanity? This is where tonight gets genuinely strange, stranger than any machine we've imagined so far. 50 million years. The last time Earth had 50 million years to play with, our ancestors were small, nervous creatures in the shadows of much larger things, and it made whales, bats, elephants, and us out of them. A settlement around a far star, founded by our descendants, doesn't stay a colony of us. It can't. Its people, whatever people means to them by then, live under different light, in different gravity, with mail from home that takes 10,000 years each way. No conversation survives that. No government survives that. No language survives that. Within a few million years, the galaxy wouldn't hold one humanity. It would hold thousands of humanities, cousins beyond counting, each one remembering Earth the way you remember a house you lived in before you could talk. Not an empire. Nothing like an empire. A family scattered so widely that its reunions are impossible, held together by nothing except where it all began. And we don't have to guess at this, because our species has already run the experiment once, in miniature, on this planet. A few thousand years ago, people in canoes began crossing the Pacific under the stars, island to island, generation by generation, until their descendants were scattered across an ocean that covers a third of the Earth. Same origin, same ancestors, same language once. Give it mere centuries of separation, and the languages had drifted apart. Give it longer, and islands forgot each other entirely. Kept only stories of a homeland over the water. Argued later about which direction it had even been in. And that was one species, one ocean, a few thousand years, with every island reachable in principle by anyone brave enough. The galaxy is that, stretched a millionfold, with the bravery not even helping, because the distances themselves forbid the visit. Whatever Latin was to the villages that slowly turned it into Spanish and French and Romanian, Earth will be to the thousand humanities, the old mother tongue, the place the stories start, a word that mostly means long ago, and the drifting won't only be in the languages, it'll be in the bodies. This is the part of the third rung people flinch from. So let's hold it gently and honestly. The worlds of the scattered family won't be Earth's. They'll be heavier, lighter, dimmer, redder, stranger, and life reshapes itself for its home, always has. Some settlements may guide that reshaping deliberately, tuning their children for thin air or long nights, the way we already tune crops. Others may drift the old way, letting time and place do the sculpting. Give it 1,000,000 years and the family album fills with cousins who could not share a room or an atmosphere with each other or with you. And the strange comfort is that this isn't a new story either. You've already survived it. Every human alive is the unrecognizable descendant of something that would not recognize us. And no one experiences that as loss, because nobody along the way ever stopped being someone's child. The chain never breaks. It just grows longer than any memory. Humanity was never really a shape. It was a relay, which is why the third rung asks for a virtue no species has ever had to practice. And it isn't courage, and it isn't genius. It's the cathedral builder's virtue. In the old stone towns of Europe, there are churches that took centuries to raise. The great cathedral at Cologne was begun in the 1200s, and the city ran out of money and conviction partway through, and for generations, a wooden crane simply stood on the unfinished tower, waiting, part of the skyline for so long that people forgot it was temporary. The cathedral was finally completed more than 600 years after the first stone, from the original medieval plans, by builders whose world the first masons could not have imagined. 600 years, 20 generations. And the masons who cut those foundation stones knew, with total certainty, that no one they would ever meet, no child of their child's children, would stand under the finished roof, and they cut the stones anyway. Ask yourself honestly whether you'd take that job, cutting stone all your working life for a roof you'll never stand under, and notice that the question is slightly dishonest. Because you already have. Everyone does. The language you think in was built by people who never met you. The laws that let you sleep safely, the vaccines in your blood, the wires in your walls, all of it is roof. Raised over you by masons who knew perfectly well they'd never see your face. Living downstream of strangers' patience is the ordinary human condition. The third rung doesn't ask our descendants to become something unprecedented. It asks them to keep doing the most human thing there is, at a scale the first masons would have understood in their bones and admired. A rung 3 civilization is that, stretched 100,000 times longer. Whoever launches the first seeds toward the galactic core will be, to the civilization that finishes the work, what the first fish that crawled ashore is to us. Not a founder they remember, but an ancestor they can barely imagine. The project outlives every builder, every language, every institution, every idea except the project itself. And still, stone by stone, star by star, it can be done. Nothing forbids it. The universe permits cathedrals of any size. It just prices them in patience. Before we stand on the top rung, let's compress the whole climb once into something a mind can actually hold. because 100,000 century numbers slide off, even when you're wide awake. So put the entire journey, from tonight to the finished galaxy, onto one calendar year. Call tonight midnight on the 1st of January. On this calendar, the climb to rung 1, those 3 or 4 spreadsheet centuries, is over within the first few minutes after midnight. The fireworks are still going, and the planet is already harvested, the deserts already greened. The climb to rung 2, the swarm, the dismantled planet, the garland of handmade counties, all of that is done before dawn on New Year's Day. Before breakfast, the star. And then the rest of the calendar, the whole long year, the 350-odd remaining days, is the wave. Seeds drifting, settlements waking, languages splitting, the slow tide of the family spreading arm over spiral arm, February, May, August, the galaxy filling the way a garden fills across a summer, and the finished thing, the smouldering, thinking, letter-writing galaxy, arriving only with the last days of December. That's the true shape of the ladder. The parts that sound impossible tonight, the fusion, the swarm, are the first morning's work. Almost the entire story is just the walking. Patience isn't one of the requirements. Patience is the project. And so, somewhere between 5 million and 50 million years after some version of us launches the first seed, it's done. Rung 3. And I want to walk through what the finished thing actually is, slowly, because there may be no bigger object a mind can try to hold. A galaxy, 400 billion stars, and around essentially every one of them, machinery. Swarms drinking dwarf stars and giant stars, settlements warmed by suns their builders chose. The empty light that once poured uselessly into the dark between galaxies, all of it caught, all of it used, all of it turned into thought and warmth and whatever our 1,000-descendant humanities have decided living means. The galaxy's great rivers of energy redirected, stars themselves herded, over ages, into more convenient orbits, the way rung 2 learned to steer one Sunday picture, that herding for a second, because it may be the gentlest colossal thing imaginable. No force, no dragging, nothing so crude. You place masses, you time approaches, you use one star's gravity to bend another's path by a whisper, and you wait 100,000 years, and the whisper has become a new orbit. Shepherding by arithmetic. A civilization doing this doesn't experience it as patience, any more than you experience a kettle's minute as an ordeal. On their clocks, moving a star is simply a task, begun on a Tuesday, finished on a Tuesday, with 100 millennia of quiet in between. Even the monster at the center, the black hole 4 million times our star's weight, put to work. And this deserves a slow minute, because it's the strangest kindness in all of physics. How do you get power out of a black hole? It sounds like the opposite of a power source. Nothing escapes it, famously, not even light. But the trick was never to take anything out of it. The trick is in the falling. Lower matter toward a black hole patiently, the way you'd lower a bucket down a well, and the fall itself releases staggering energy, given off as light and heat on the way down, before anything crosses the point of no return. Nature already does this, sloppily. That quasar that fooled Moscow in 1965, the one mistaken for a civilization, was exactly this. A black hole messily feeding, outshining its whole galaxy on spilled gravity alone. Done deliberately, with rung 3 care, the falling of matter gives back its energy dozens of times more richly than fusion does. Fusion, the miracle we've spent 70 years chasing, turns a fraction of a percent of its fuel into light. A well-run black hole returns a substantial slice of everything you feed it. It is, quite literally, the best furnace physics permits. So, the most fearsome object in the galaxy ends the story running as the hearth at the middle of the house, warming the deepest rooms, fed by hand. The thing that fooled us into imagining civilizations becomes the thing civilizations are built around, and some of the structures on that rung make even the Dyson swarm look shy. Around some stars, the swarm wouldn't power homes at all, layer upon layer of collectors, each shell feeding on the waste warmth of the one inside it, the whole nested thing existing to do nothing but compute. A machine the size of a solar system, thinking. What does a mind like that think about? Whole simulated worlds, perhaps. Histories rerun with one thing changed. Mathematics no biological brain could hold one page of, nobody knows, and the not knowing is the point. Let's do what we did on the neutron star night, and simply visit. Put yourself on one of the inner worlds of the finished galaxy, a settled place deep in the core regions, and give yourself one night there. The first thing you'd notice is the sky, because nobody raised near the core has ever seen darkness like yours. Stars there crowd so thick that night is a formality. Thousands of suns hanging close enough to read by, and threaded among them, if you know how to look, the neat amber points of wrapped stars, blankets glowing their warmth out into the dark. Down one avenue of the sky, a soft, structured shimmer that isn't stars at all, traffic of light, the mail of the thousand humanities, passing forever. And low on the horizon, where a mountain range would be on your world, a dim, steady glow the locals barely mention, the way you barely mention the moon, the hearth itself, the great black hole, 4 million suns worth of patience, drinking its careful diet, warming the oldest rooms of the house. A child there falls asleep under all of that the way you're falling asleep under a ceiling, because it's just the sky, the only one she's ever had. Wonder, it turns out, doesn't live in the view. It lives in the distance between the view and home. Hers is tonight's whole galaxy. Yours, for the record, is a window with a kettle's worth of starlight coming through it, and she would find that unbearably romantic. There are pilgrims in her world, in fact minds who spend a century of travel just to visit the outer dark, the thin unlit fringes of the galaxy, where the stars come one to a sky and the night is almost as empty as yours. They go for the same reason our centuries' travellers cross oceans to stand in deserts, to feel the old scarcity, to see what the ancestors saw, which is to say, almost nothing, one small fire at a time. Out there on the rim, in the quietest suburbs of the finished galaxy, the sky on a clear night looks very nearly the way it looks tonight through your window. It's considered in her civilization one of the great views. Asking what a rung 3 civilization does all day is the worm's question about the librarian. We met that gap on our Fermi night, from below. Tonight, for one strange hour, we've been imagining it from above. Is there anything past the 3rd rung? People asked Kardashev. Of course. If 1 is a planet and 2 is a star and 3 is a galaxy, then surely 4 is the whole universe, and enthusiasts have sketched exactly that. Civilizations harvesting the light of every galaxy at once. Kardashev himself never extended the ladder. By most accounts, he found anything past the 3rd rung unnecessary to talk about, and there's a wisdom in where he stopped. Beyond rung 3, the universe itself starts declining to cooperate. The other galaxies are sailing away from ours, carried on the expansion of space, and nearly all of them can never be caught by anyone at any speed, ever. Our neighbour Andromeda is the exception, close enough at 2.5 million light-years that it's actually falling toward us, due to arrive and merge with the Milky Way in about 4 billion years. A rung 3 civilization wouldn't even need to travel to claim a second galaxy. It could simply wait for the delivery. Beyond that, the shore. The ladder ends not because ambition runs out, but because the universe only put 3 rungs within reach, which makes the 3rd one not a stage in an endless climb, but something stranger and more final, just the top, the most that any mind, anywhere, can ever inherit. Now. Here's the moment the whole night has been climbing toward, and it's not a new wonder. It's the blanket coming back. Because think about what that finished galaxy looks like from outside, from another galaxy entirely, through a telescope. Every wrapped star has gone dim to the eye and warm to the instruments. 400 billion blankets, the whole galaxy's visible light fading, generation by generation, while its warm glow swells. A finished, inhabited, rung 3 galaxy wouldn't blaze. It would smoulder, dark to the eye, warm to the right camera. A galaxy tucked in for the night. And here's the thing. We know exactly what that would look like. We know it so precisely that about a decade ago, astronomers went looking for it. If you were with us on our Fermi night, you know this survey, and you know what it found. A team of astronomers took an infrared space telescope, the kind of camera that sees warmth, and combed through 100,000 galaxies. Not looking for signals, not looking for ships, looking for blankets. For any galaxy dimmed in starlight and swollen with waste heat. Any galaxy where somebody had finished, or even half finished, the climb we've spent tonight describing. 100,000 galaxies, each one holding its own hundreds of billions of stars, each one billions of years old, which is time enough to run tonight's whole story from kettle to completion many times over. So what did they find in all those 100,000 galaxies? They found dust. They found star nurseries. They found the ordinary, glorious mess of the universe. And they did not find one single galaxy wearing the blanket. Not one finished, not one half done, not one plausibly begun. And there's a human coda to that result that belongs in tonight, because the man who drew the ladder lived to see it. Kardashev never stopped. Through the fall of the country he'd drawn it in, through half a century of empty results, he kept working, kept listening, kept helping design bigger and stranger radio eyes. Into his 80s. He died in 2019, still convinced the search itself was among the most important things a species could do, still gently unbothered by the silence. Someone once asked him, late in his life, about all the decades of finding nothing. His answer, in spirit, was the answer of every cathedral mason on tonight's ladder. The size of the question is the reason for patience, not against it. He drew a ladder 3 rungs high, watched the universe decline to show him a single climber, and went on believing the climb was there to be made. Whether that's stubbornness or wisdom is one more thing nobody knows. But it's hard to think of a better patron saint for the night shift. Hold that result the way you'd hold something fragile, because it can mean such different things, and nobody on earth knows which. And notice what it's already done to you. Quietly. Just now. The next time you see one of those deep photographs of the sky, thousands of galaxies scattered like spilled sugar, some part of you will check. You'll find yourself looking, without meaning to, for the dim one, the warm one, the one wearing the blanket. That's what tonight actually changes. Not the sky, the looking. Every person who has ever really understood the ladder carries that small extra glance for the rest of their life, and now it's yours. The cold reading says, the climb never happens. Something always stops civilizations before rung 3. And the ladder we've spent all night ascending is a beautiful staircase to nowhere, drawn by a young species that hasn't learned yet why everyone else stayed home. But notice that the warm reading fits the same evidence exactly as well. Maybe the ladder is real and simply unclimbed. The universe is young, remember. On our night about the first ones, we walked through how nearly every year the universe will ever have is still ahead of it. How the stars are barely getting started. Maybe 100,000 empty galaxies doesn't mean the cathedral can't be built. Maybe it means nobody's laid a foundation stone yet. Somebody has to be first. And if you were with us on our night about the first ones, you know the universe's own calendar backs this reading more than it seems to. The cosmos is early. The long-burning stars have barely started their lives. Nearly every year the universe will ever have is still to come, and a species showing up now ladder in hand, isn't late to anything. It's absurdly, almost embarrassingly early, the first guest at a party scheduled to run for trillions of years. Nothing anywhere in physics says the first climber can't be the species that invented the kettle. And there's a third reading, the quietest one. And after our last few nights together, you can probably feel it coming. Maybe great civilizations don't climb out. Maybe they climb in. Every rung of Kardashev's ladder assumes that bigger is the direction of wisdom, that a mature species wants more stars, more light, more reach. But think about the actual direction of every technology you own. Smaller, denser, quieter. We met this on our Fermi night, minds folding themselves into something the size of a teacup, whole civilizations gathering into one warm inner room and closing the door on the winter. And we met the elders who might be sleeping through the universe's warm morning entirely, waiting for the deep, cold ages when every thought comes cheap. If that's what maturity looks like, then the ladder isn't wrong, it just bends. Rung 1, rung 2, and then inward, downward, into stillness, into an economy of thought no telescope could ever see. Maybe the galaxies look unclimbed because the summit was never up. And in fairness to the whole night, you should hear the doubters properly before we choose no side at all, because some very thoughtful people suspect the ladder itself is the mistake, and their reasons are worth falling asleep on. The first reason is written in our own recent history. For 2 centuries, more civilization always meant more energy. The 2 lines climbing together like ivy. Then, quietly, a few decades ago, in the world's most developed places, the lines came apart. Energy use per person flattened, even fell, while life went on getting richer, faster, deeper. Your phone replaced a room full of humming machines and sips less power than a light bulb. Every year, our computing does astonishingly more per drop of energy than the year before. Maybe that's not a blip. Maybe that's the actual curve of maturity, not appetite growing forever, but appetite peaking and wisdom learning to do more with less, all the way down into the cold, thrifty, teacup futures we visited on our Fermi night. If that's the true curve, then nobody builds Dyson swarms for the same reason. Nobody builds bigger and bigger gramophones, not because they failed, but because they grew past the want. And the second reason is gentler still, and it's about us, not them. Every age imagines the future in its own costume. The Victorians, drunk on steam, drew futures of brass and boilers, cities of pistons, because steam was their miracle, and they assumed it was everyone's. The 1960s, the decade of dams and moonshots and reactors, of energy as destiny, drew the Kardashev scale. It's a 1960s future. Magnificent and sincere, drawn by a civilization whose miracle was mega-projects, and it may say more about that decade than about any actual tomorrow. Our own age, notice, has quietly started drawing different futures, futures of intelligence rather than wattage, of depth rather than reach. Which future is the costume and which is the destination? Nobody can stand outside their own century to check. The ladder might be prophecy. It might be a period piece. The sky, which has read every century's drawings, keeps declining to grade them. And for completeness, on a night that has tried to be honest, there's even a physicist's footnote to the blanket itself. The waste heat argument assumes the climbers compute and build the way we do, sloppily, shedding warmth with every thought. But theorists know that computation can, in principle, be done almost without waste, each operation folded so carefully that nearly nothing is lost, and a civilization far enough up the ladder might run astonishingly cool, its blanket thin, its glow faint, its presence hidden not by intent but by sheer good housekeeping. If that's common, the survey of 100,000 galaxies proves less than it seems to. The searchers know this footnote, and they'll tell you it can't be the whole story, since harvesting starlight at galactic scale should still leave shadows and dimmings we'd catch. But it thins the verdict. Even the blanket, our one honest way of seeing the ladder from afar, might miss the tidiest climbers. The universe doesn't just keep its answers, it keeps its bookkeeping in pencil. Nobody knows, truly nobody. And here's why the not knowing is not a disappointment, but the whole gift of tonight. Every one of those readings hands our species a different, extraordinary place in the story. Either the climb is impossible, which would mean the quiet sky above your roof is the whole show, and this one lit world is carrying it. Or the climb is possible and unstarted, which would make us, absurdly, the early ones, the species that gets to cut the first stone. Or the climbing goes inward, and the far future of intelligence looks less like an empire of stars and more like what you're doing right now. Lying still, warm, using almost nothing, thinking. You don't have to choose a reading tonight, and the evidence wouldn't let you anyway. But you might notice, drowsily, which one you were rooting for just now. Some listeners want the ladder real and waiting, the empty galaxies an invitation with our name on it. Some feel the tug of the teacup futures, all that striving folded into something small and wise and warm. Some are quietly relieved by the thought that everyone stays home. None of those is the correct answer, but yours is a real answer to a different question, the question of what you'd want written on the biggest possible wall. Carry it lightly. Species change their minds on this. Same as people. Same as centuries. Whichever reading is true, tonight ends the same way. The ladder stands there in the dark, unclaimed, patient, forbidden to no one. There's one more honest thing to say about the ladder, and then we can start back down toward bed, because even the top rung has a ceiling, and it's one we've met before. Does the ladder ever escape the bill? All that energy, planetary, stellar, galactic, every rung of it is spending, and the universe keeps one set of books. This was our night about the fire, if you were with us then. Warmth flows one way, everything runs downhill, and nothing gets to opt out. A rung 3 civilization commanding 400 billion stars is not exempt from the second law of thermodynamics. It is the second law's biggest customer. Every wrapped star is still a fire burning down. Every Matryoshka mind is still spending an inheritance nobody can top up. Even the grandest possible civilization is a guest of a cooling universe, keeping itself warm by the same one-way flow that cools your tea. The ladder doesn't lead out of physics, it just buys the longest, brightest possible stay inside it. And there's something almost tender about that. The mightiest thing imagination can build, a galaxy fully lit and fully thinking, still lives the way you do tonight, on borrowed warmth, spending it carefully, hoping to make it last until the end of the story. Though notice what a stay it buys, because the same bookkeeping that says the fire must eventually burn down also says a careful civilization gets to choose how slowly. The universe's deep future, we learned on the fire night, is long past imagining, trillions upon trillions of years of cooling dark. And thought gets cheaper as the cold comes on. A rung 3 civilization that banks its stars, lifts and stretches them, herds its fuel and spends like a winter household, isn't buying centuries with all that power. It's buying a span of existence so long that the entire age of stars, everything from the first light to the last, becomes the brief, bright childhood at the beginning of its story. The ladder, climbed all the way and then managed wisely, is how mind gets to stay for the whole show. Not forever. Nothing is forever. But for as close to forever as the universe sells tickets. Stand at the bottom one last time then, and look up the whole height of it in a single breath. A kettle, 3,000 watts for 3 minutes. A civilization of kettles, 0.73, everything humming on Earth tonight. 10,000 of those. And you hold a planet, rung 1. 10 billion of that. And you hold the star, it circles. Rung 2. 100 billion of those stars, herded and blanketed and poured into thought across 100,000 light years. Rung 3. The top. The most the universe rents to anyone. That's the ladder, the whole of it, and every rung is made of the same single trick you performed without thinking this morning. Energy in, change out. Water sat in a metal jug, and energy poured into it, and the water changed. There is nothing else on the ladder. There is only that, repeated, until it holds a galaxy. So come back down now. Rung by rung, gently, the way you'd come downstairs in a sleeping house, down from the smouldering finished galaxy, past the herded stars, past the minds the size of solar systems, down to rung 2 and the swarm glittering around one ordinary yellow star, the clear corridor of light still falling faithfully on one blue world. Down to rung 1, the quilted deserts, the planetary grid breathing power around the globe like slow blood. The Tuesday people who've forgotten their kettles were ever miracles. Pause one last time on the first rung on your way past, because it reads differently on the way down. Coming up, it was a mountain, 10,000 times everything we have. Coming down, from where you've been tonight, it's the little landing barely above the ground floor, the one the elders of the finished galaxy would struggle to see at all from their height. Both are true. Every landing on every staircase is enormous from below and quaint from above. And the only cure for the vertigo, in either direction, is the one the climb itself teaches. You take the stairs the way everyone takes them. Everywhere, on every rung there will ever be. One at a time. And down one last step. Below the ladder entirely, to a small world where the lights are going off one time zone at a time. Here, tonight, at 0.73, on the approach walk, the species that has drawn the whole ladder and not yet touched it. And now that you've seen the whole climb, look around your room one more time, because here's the secret the ladder was keeping all night. Every rung already exists in your house, in miniature. The fire that started the whole story, tamed into a stove. The captured sunlight, sitting on rooftops down your street. The planetary grid, humming behind your wall right now, delivering the harvest of distant turbines to the lamp beside your bed. Your house is the ladder, at kettle scale, and the climb, all of it, the swarms, the seeds, the smouldering galaxies, is nothing but what our species has always done again, larger. Some ancestor of yours, on a night colder than this one, banked a fire so the warmth would last till morning. Rung 3 is that, exactly that, a fire banked so well, and tended so patiently, that the morning it's saving up for lies 100 million years away, and the family it keeps warm is every mind the galaxy will ever hold. And there's one more person in tonight's story, easy to miss, because she hasn't been born. Somewhere far up the ladder, if it's ever climbed, on some warm, handmade county, circling a banked and tended star, a mind will one day wonder about the beginning. Not about the swarm builders or the seed launchers, they're the famous middle chapters, about the beginning. The little world at the bottom of the ladder where the whole thing started. Where the species that lit the galaxy once lived all together in one place, cooked with fire, slept in the dark, and looked up at the stars it didn't own yet. To her, that world is scripture and legend and half-lost data. To you, it's Tuesday. You live in the age her whole civilization will ache to know one true hour of. The ordinary evening you're having right now, the kettle cooling in the kitchen, the rain, if you have rain, the specific weight of your blanket, is the deep ancestral morning of everything on the ladder. Nobody up there will ever get to visit it. You're in it. So what's the first stone of the cathedral? It isn't a machine. Nobody alive tonight will mine mercury or seed a star. and none of the great work needs anything from you before breakfast. The first stone is smaller and nearer than that. It's a civilization that keeps itself. That gets through its young, clumsy centuries with the lights on, that carries the kettle and the garden and the sleeping child safely across this decade to the next one, and hands the whole unfinished project forward, the way it has been handed forward, hearth to hearth, for 300,000 years. That part is going fine tonight. The grid is humming, and the harvest is falling toward tomorrow's rooftops, 8 light minutes out and right on time. And the only thing the ladder asks of you, its earliest and luckiest climber, is the thing your body is already asking for. Bank your own small fire and rest. So let the whole climb go now. Let Mercury keep its metals and the seeds stay folded in their futures, and let the 1,000 humanities wait, unhurried, on the far side of 100,000 centuries. None of it needs holding tonight. Listen to the house for a moment before you go. Somewhere behind your wall there's a faint hum, the grid, the planetary bloodstream, moving its harvest through the dark. A refrigerator keeping its small winter. Maybe a kettle, cooling, ticking softly as the metal lets go of the evening's last warmth. That's what 0.73 sounds like. That's the bottom of the ladder. Purring. Every civilization on every rung, real or waiting, falls asleep inside some version of that sound. The sound of banked energy minding itself till morning. If your thoughts drift back up the ladder as you fade, let them drift gently. The way you'd watch a kite you're no longer holding. The stars will still be there, unclaimed and patient, tomorrow evening. The kettle will still work, and the morning will arrive on schedule, delivered across 93 million miles at no charge, the first installment of everything this whole night was about. The universe has been keeping every civilization that ever tried warm on the same steady payment, and yours is paid through morning, and through every morning after that, for 5 billion years. And should you wake in the small hours, the way sleepers sometimes do, and find the room dark and the house quiet, remember what you now know about that quiet. The grid is still leaning gently around the planet, evening lands drinking from morning lands. The sun, 8 light minutes up the road, is spending its 4 million tons a second, absolutely regardless. The whole first rung of the ladder is out there idling faithfully in the dark, keeping the refrigerators cold and the wards lit and the early bakeries warming. And it does not need you awake to supervise any of it. The watch, as we said on another night, is kept in shifts. Yours is over. Roll over, find the cool side of the pillow, and let the 100-watt device power down properly this time. If you're still awake and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, just stay here, in the warm, one rung below the bottom of the ladder, in the one place in the whole climb where sleep was ever invented. The stars will keep spinning while you sleep. Good night.